Let's take some time and talk about computer numeric control. Computer numeric control, or CNC, is the method in which computers control the movement of machines. Now, what do I mean by that? Well, everything from large robots that assemble automobiles and even 3D printers are computer numeric control machines, meaning the computer is feeding numbers into the machine and the machine is performing that action. Now, the language that these machines all speak are all the same, or variants of the same thing. That language is called Gcode. Gcode is a simple language structured by a letter followed by a number that is fed to the machine to perform an action. For example, G1. A machine might receive a G1 and it would know that it needs to move a part of its machine. Now, let's look at a couple real-world situations. We are looking at a Gcode file for a tiny cube object being fed to a 3D printer. This is a real-world object. Let's take a look at the structure of the Gcode. The first thing you can see is we have comments. Comments begin with the semicolon, and the comments can contain anything. These comments are human readable, and it gives an engineer an idea of what function is going to be performed, so he or she does not have to memorize each command. Down here you can see we're sending the machine G21, letting the machine know that the parameters we are going to send it are going to be in millimeters. And so any movement of any part of the machine is going to be done in millimeter increments. So any movement by the machine is prepended by the G command. G0 might tell the machine to use any rapid movements. G1 might tell it that it's actually going to start feeding or cutting or extruding or moving to another position within its feed rate. Commands that begin with an M are miscellaneous commands. Like I said before, every machine that is CNC controlled, whether it's a robot assembling a vehicle or a 3D printer, uses these commands, but not every machine has the same apparatus. For example, a machine that welds the doors onto a car might have a welding tip. A 3D printer has an extruder, and it's not going to have a welding tip, so you have to give a different command. These commands are prepended by the M command, and those can be assigned to different miscellaneous operations. For example, this command, M104, tells the machine it's going to set the temperature on the extruder. The S command, with the 190, tells the machine it's going to set the temperature to 190 degrees centigrade. Now remember, we talked about the G commands being for movement. So the G28 tells the machine it's going to home all of its axes to the starting location. G1 tells the machine it's going to move a piece of its machinery. In this case, we're going to move the Z axis up 5 millimeters. The F tells it how fast to actually move. So in this case, we're going to travel at 5,000 millimeters per minute. Here are some typical examples of machine movement. To actually draw or extrude the material in the right pattern, we're going to give it a series of G1 commands. In the beginning here, we're going to send the G1, meaning we're going to start our actual operation. We're going to move the Z-axis to 0.2 millimeters at a feed rate of 7,800 millimeter per minute. This in effect tells the extruder to go 0.2 millimeters right off the build platform. The next one, now we're telling the machine to move the X-axis 105 millimeters and the Y 100 millimeters. This allows the machine to center the extruder onto the build platform. We are now going to send a command using the E command to activate the extruder, or actually start spitting plastic out of the nozzle. This is going to be done at 1800 millimeter per minute. This repeats until you have a complete picture. By sending it a series of coordinates, the machine then travels to that coordinate, and with the E command, extrudes plastic as it travels. This is the bare essentials of how the extruding 3D printers work. It does not get any more complicated. This process continues over and over and over again until the first layer is deposited. Each one of these numbers is actually drawing a line on the pattern for each layer. Now, let's scroll down here and take a look at the end of the layer. What we're looking at in this chunk is we're actually turning off the extruder. We're going to back off the plastic a little bit so it doesn't ooze out. And now we're going to set our layer height, our Z-axis, to 0.4 millimeter. So now we're on to layer 2. And the process repeats until layer 3. Let's go to the bottom. The process repeats until the entire print is finished. At the end of the print, we're going to back off the plastic by sending the E command to reverse extruding 33 millimeter. G92 turns off the extruder. We're now going to set the temperature at 0, or effectively turn the heater off. We now home the x-axis so the extruder is out of the way and the user can reach in and remove his object. And we're going to turn off the motors so that they do not activate anymore. And that finishes the print. The comment at the end tells you how much plastic was actually used in this print, which is handy to know if you're budgeting for your plastic.